Guys, today we're covering 5.9, which is systems of linear inequalities. Just to shorten, I just wrote inequalities. So let's talk about what this means when it says systems of inequalities. That is two or more linear inequalities that are graphed together. Now, the solution to a system of linear inequalities, it is the overlapping or double or triple shaded region of points that satisfies, which means makes true, both inequalities. All right, so let's see what that looks like when we actually graph. Okay, so for number one, it's great when it's already in y equals mx plus b form, which these nicely are. Okay, so we've got to remember our rules. This is both going to be dashed lines because there's no equal to bars. So I have my y-intercept. I always start with my y-intercept first. Let me pull this out. So I have m equals -1, b equals -1. So I start at -1, and then I have a slope of -1 over 1. So that means I'm going down 1 over 1 here. So it's pretty much, I can just do dots, which will make it so it's either a dashed or dotted line. I don't need to use a straight edge because I'm not connecting them. Now, it's y is greater than, so therefore I am shading in this direction. I'm not going to actually shade right now because my actual solution is the double shaded or the overlapping region. Okay, it's nice when you have two different colors because you can easily see that. Okay, so for this one, my slope is 1. My y-intercept is -5. So I start at -5. 1, 2, 3, 4, 5. This is a positive slope. So it's going to go in this direction. And it's 1 over 1. So there's the actual intersection point right there. But this is inequalities. So therefore, there's not one solution. There's multiple solutions to this. And yes, you continue your pattern all the way through. And I should have put arrows on the end of the orange line because these are lines. Okay, so now it says less than. So if it's y is less than, that means I'm shading below the line. Now, the solution is the area that actually has both colored arrows. So this here is my solution area. The solution is a graph when it comes to the inequalities. And any point in this region is a solution to this system. All right, let's practice another one. Number 4. What they changed about number 4 is one of them is a vertical line, and then this other one is not in slope-intercept form yet. So one thing I can say is right away, this is vertical because it's x equals, so it's going to cross the x-axis at -4. But again, this is a dashed or dotted line because it does not have the equal to bar. and it's everything that's less than. So that means I'm shading in this direction. Okay. Next. Well, for this one, I've got to rearrange. I've got to solve for y. So I'm going to subtract the 3x from both sides. And I now have 2y is less than or equal to negative 3x minus 2. Divide by 2 to everything. And I get y is less than or equal to negative 3/2 x minus 1. So for this one, my slope is negative 3/2. My b is negative 1. Okay, this is a solid line because it has the equal to bar. So here I'm going to need a straight edge. All right, so I start at negative 1, and then I use my slope of down 3 to the right 2, down 3 to the right 2. And I go in both directions, so I make sure that I'm accurate. It's very important that you are accurate with your graphs. There's the point of intersection if it's just the lines. And here we go. Now, if y is less than or equal to, so it should be below, but since it's standard form, I'm going to check with 0, 0. So that's going to give me 3 times 0 plus 2 times 0 is less than or equal to negative 2. So that's 0 is less than or equal to negative 2. That's a false statement. So therefore, the point 0, 0 should not be in my shaded region. Not in. 0, 0 is not in shaded region. So therefore, again, I'm shading below. Remember, I only want the double shaded region, which is this area here. The brown or the darker color is the double shaded region. Okay, one more. Well, two more actually, because we want to do the word problem too. All right, looking at number 9. We've got to rearrange. So this is going to become negative y because I've got to subtract 3x. So I'm going to have negative y is less than negative 3x plus 6. We've got to divide by a negative 1. So this is going to become y is greater than 3x minus 6. Okay, so negative 6, 2, 4, 6. Okay. I've got a slope of 3, so up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and that's it. This is a dashed line, so I'm going to make sure I've got dashes going on here. It says y is less than, so therefore I'm shading in this direction. Okay. The next line. Oh, wait a minute. That's greater than, not less than. I just shaded in the wrong direction. Because that's greater than. So that means it's above. We're shading in this direction. All right, next line. We're subtract the 3x. So we end up with negative y is greater than negative 3x minus 2. Divide by negative 1, and we have y is greater than 3x plus 2. So we have the plus 2 is here, and then we have our slope. It's positive. Oh, these are slope. These are parallel lines. These were just the equations, then it would be no solution. But the problem is these are inequalities. So there's a difference. All right. This is less than. Oh, I didn't flip it. This is what happens for Miss Wilson. Because we're dividing by a negative, we have to flip the inequality. So this is less than, so therefore I'm shading in this direction. Well, I got to look to see what's the overlap. The overlap is everything in the middle. It's everything that's in the middle that's the overlap. All right, let's look at the application problem now. Okay. Sarah's pet store never has more than a combined total of 16 cats and dogs. Okay, so we've got a combined total of 16 cats and dogs. Can I have a negative amount of dogs and cats? Remember that. Okay, that's why we only have one quadrant on the graph. She also never has more than 9 cats. Write a system of inequalities. So we have to write a system of inequalities and graph to show the possible number of cats and dogs in her store. All right, so first things first, we label the variables. Let's let x equal the cats, y equal the dogs. Okay, so over here we got a label. So this is cats and this is dogs. Okay, so now we have that it has more than, never has more than a combined total of 16 cats and dogs. Therefore, it's going to be less than or equal to 16, and I'm going to have x plus y. But then it also has never has more than 9 cats. So that's going to be x has to be less than or equal to 9. There's my system. Now we graph them. I'm going to graph this one first. So that's a vertical line at 9. So I'm going to have 2, 4, 6, 8, 9. So that's here. And it's got the equal to, so it's a solid line. And it's never goes above it, so therefore I'm shading this direction. Okay. Next, we got to rearrange. So this is going to become y. Oh, I already used orange. Make a different color. Y is less than or equal to negative x plus 16. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, which is here. And then it's a negative slope, so therefore it's just dots all the way down. And I can plate connect the dots with this as well, because this needs to be a solid line because it's equal to. Okay, now it's y is less than or equal to, so I'm shading in this direction. So that means the solution is this little trapezoidal area here. That is my solution to this application problem. That means any ordered pair in this area is a solution. If it's an area here, it's not a solution. An area, a point here, not a solution. Point here, not a solution. Point here, not a solution. Okay, have a great day.